Today we're going to talk about solving equations using fractions and decimals. So this is going to be pre-algebra level or algebra level, talking about solving equations and the steps to go through when we're using fractions and decimals. So here we go. When we're using decimals, we need to remember that the equations usually have a piece that is something times x plus or minus something else is equal to another number. So if we have fractions or decimals, it's really no different. So our steps are going to be combine like terms, and then we're going to make zero pairs and do opposite operations. So in order to do these, let me erase this a little bit so that I'm not in the way of my solving. Okay, so when I'm combining like terms and doing zero pairs and opposite operations, I'm going to first take the time to group things according to their terms. So things with an x, I'm going to put a box around. That just helps me keep track of what is what. So far, I have 1.4x and 2.35x. Well, if I combine those two, I can take this and I can put it under here. So I've got 1.4x. And so when I add those, I've got 3.75x. So this goes away. So I've got negative 1.8 plus 3.75x is equal to 0.21. Now, that's me. I combine like terms. So now the only things I have left on the left side of the equation are this negative 1.8 and this plus 3.75x, and that's equal to 0.21. Well, now I need to do zero pairs, and I recall that zero pairs allows me to get rid of everything that doesn't have an x with it. So I'm going to zero pair with this, which means these together make 0. But I know I need to do the same thing to the other side. And so when I find my totals, I've got 3.75x is equal to 2.01. Well, that was zero pairs because these make a 0 right here. Okay? And so now when I do my opposite operations, I'm eliminating the number in front of x. And so when I do opposite operations, I'm going to divide by 3.75 on both sides. Okay? So I'm left with x is equal to now 2.01 divided by 3.75. You can put that into your calculator or you can multiply it out. It is 0.536. A good way to check that would be to put it back into the equation. I am not going to show you that right now. That's for a different day. So I did combine like terms, zero pairs, and opposite operations. Okay, so let's look at one with fractions. We need to remember that fractions are really just decimals that haven't been converted to decimals yet. So we haven't actually done the division. So we're still going to use the same steps. Combined like terms, zero pairs, opposite operations. I can see that I have something with an x in it on either side. So what I'm going to do is I'm going to try to get them both to the same side. Well, conveniently, this is already negative. So I'm going to add 1/6 x to both sides. So what I've got here is 3/10 x plus 1/6 x is equal to 7/10. Now, I can't necessarily add those two things together as they are, so what I'm going to do is I'm going to find a common denominator. Well, I can see that 10 and 6 both go into 30, so what I'm going to do is I'm going to multiply this by 3 over 3. I'm going to multiply this by 5 over 5. Now, I don't need to do that to the other side because really what I'm doing is unreducing the fraction. So it's not like I'm multiplying this whole side by something that I need to multiply the other side by. I'm just simply taking these individual pieces and multiplying them to make a fraction that's unreduced. And so when I come down to this level, I've got 9 over 30 x plus 5 over 30x is equal to 7/10. So once again, I didn't have to multiply that by the other side because I simply had an unreduction of the fraction. So if I reduce these two fractions here, 9 over 30 and 5 over 30, I would have what I had in the previous line. So now I can add these. So I've got 14 over 30x is equal to 7/10. And just for clarity's sake, I'm going to come up here to this line. And I've got 14 over 30 x is equal to 7 over 10. Now, I'm going to reduce first. I'm going to reduce this fraction. So I've got 7 over 15x is equal to 7 over 10. Now, I have already combined like terms here. I didn't have to do zero pairs because there was nothing to zero pair up with. Now I'm going to do opposite operations. So if I'm multiplying 7 over 15 by x, to undo that, I divide by 7 over 15. I need to do the same thing on the other side. So I've got x is equal to 7 over 10 divided by 7 over 15. Unfortunately, I want to try to avoid dividing by a fraction where I can because it's complicated to put in the calculator and I don't know how to do it in my head. But what I can do is this. I can say that this is really equal to 7 over 10 times the reciprocal of 7 over 15. So 15 over 7. So what I did there was, instead of dividing by a fraction, I'm going to multiply by the reciprocal. And so when I cross reduce, 7 goes into 7 one time, 7 goes into 7 one time, 5 goes into 10 two times, 5 goes into 15 three times. So x is really equal to 3 over 2. So x is equal to 3 over 2. And so that's my problem right there. It's the same steps, combine like terms, zero pairs, and opposite operations. But what I did was I just used it in the fraction form and ended up multiplying by a fraction, which I can do. This is really not a problem. Here are 4 practice examples for you to do. I'm going to do A and D. So if you don't want to see those right now, you can go ahead and turn off or pause this so that you can do these problems and then check your work on A and D. Okay, so I'm going to do A and D. So if you feel like doing these on your own, go ahead and pause that right now. Okay, so let's look at A. When I have negative 1.7k and 6.7k equal to 13.1, I need to combine like terms first. So I'm going to do my same process here. And I know that both of these have a k in them. So I'm going to combine those and get 5k is equal to 13.1. And so then I'm going to do opposite operations. Divide by 5 on both sides. So I find out k is equal to 2.62 when I divide. Okay, so combine like terms, no zero pairs, I do my opposite operations. All right, for D, let's look at D. I think I'm actually going to do C and D because they involve fractions, which can be a little bit more complicated. So we'll look at D first. Now when I have 2s minus 1 and 1/4 s, I'm going to combine like terms. So once again, I can take this and I can say these two together both have s in them. So when I combine them, I'm going to have 3/4 s is equal to 1/3. Because if I have 2s and I subtract one of them, I have 1s, and then I subtract another fourth, that's 3/4 s. So I'm going to do opposite operations. Divide by 3/4. And I've got s is equal to, now remember, this is 1/3 divided by 3/4, which is really equal to 1/3 times 4/3. So what I can do is I can say what's going to happen when I multiply those out. Well, I'm going to end up with s is equal to 4 over 9. That's the trick right there. When I divide by a fraction, it's the same as multiplying by the reciprocal. A little bit different here. So what I'm going to do is this. I'm going to say to myself, do I have any like terms to combine? I don't. So I'm just going to go straight into it. Now, I need to eliminate the stuff that doesn't have the x, so I'm going to subtract 3 here. and that's a 0 pair. So I've got 4/5 x is equal to, now this is 3 subtracted from -7/10, so it's going to be -3 and 7/10. And so I've got 4/5 x is equal to, I'm going to convert this to from a mixed number to an improper fraction because I know I'm going to end up dividing by a fraction. And so when I do 10 times 3 plus 7, that gives me -37 over 10. I'm going to divide by 4/5. Divide by 4/5. Let's take this right here. X is equal to -37 over 10 over 4/5. Well, really that's equal to -37 over 10 times 5/4 because I multiply by the reciprocal. I'm going to cross reduce. 5 goes into 10 twice. 5 goes into 5 once. And really that's equal to -37 over 8. And that's okay. Okay? So that is solving equations with decimals and fractions. Good luck.